Hello everybody. Today in this session we're gonna have a look into one very popular concept in data sciences which we called hypothesis testing. Now the components in hypothesis testing is very useful for finding it out similarities or dissimilarities in any of the data set. Hypothesis testing can be done either for one dataset or among two or more datasets. Hypothesis testing primarily is used for various purposes. The primary purpose is to assume some keys about our data and then further validate or invalidate those thoughts or beliefs. So today in this session, we're going to understand what is hypothesis testing, and at the same point of time, we will also understand what you mean by null hypothesis and alternative hypothesis. And at the end, we will be also seeing how to carry out the hypothesis testing concepts in R programming. Stay tuned and enjoy the video. All right, everybody. Let us start understanding what is a hypothesis and how we're supposed to carry out a hypothesis testing. Any hypothesis is a confirmation about a data or an analysis what has been carried out. Whenever we have some data available, for example, we have any data represented by A, which is nothing but a collection of multiple different data items. If at all we see the data A is nothing but a collection of three different data items, x1, x2 and x3, and at the same point in time we have one more data set which is called B, and for B we do have again couple of different data items like y1, y2 and y3. At any given situation or any given point in time, we might wanted to know what is the similarity or dissimilarity between these two data sets. We can ask one specific question whether the data set A is also similar to the data set B. At any given point in time, if at all the number of elements inside any data set is limited for A and as well as for B, then element by element comparison is one of the valid possible option. I can compare x1 with y1, I can compare x2 with y2 and so on and so forth, as long as the number of elements in the data sets are very limited. And for all these comparisons, if we get one answer that yes, all these comparison results are true, then we can say that these two data sets are significantly equal. However, if at all the size of A is very high, then it is not possible to analyze each and every data elements in that particular set individually and compare them to find out whether two data sets are similar to each other or not. Now at this given point in time, we have the considered or the statistical component called hypothesis testing. Now coming back to the primary topic, what is an hypothesis? Hypothesis is once again considered to be an confirmatory data analysis where the beliefs or the thoughts supposed to be tested for that. Let us take an example and let us find out what an hypothesis can be considered and how we're supposed to do the analysis. For this purpose, we are once again taking two primary data elements or two primary data sets by the name of A and B. Let us have some data inside A and B. We are assuming that the data inside set A are supposed to be 89, 85, 90, 81, and 83. Similarly, for the set B, we are assuming that the elements of B are 19, 66, 12, 76, and 26. Now, we are having one thought or a belief saying that the set A and set B are almost similar in nature. Now, as a matter of fact, we can see that all the elements of A and B are of a same data structure or a same data type. But that will not be sufficient to make a claim that these two data sets are similar in nature. Then how I supposed to analyze that? If at all we try to calculate the mean of set A as well as the mean of set B, and at any given point in time, if at all the means are equal, then we will understand that these two data sets are fairly similar. Now, this process of finding or analyzing whether two data sets are randomly distributed or similarly distributed, we apply the concept of hypothesis. Moving little detailed in hypothesis, there are two more components or concepts which are closely related with hypothesis analysis. The first component is called null hypothesis, and the second component is called alternating or alternative hypothesis. Let us understand what you mean by null hypothesis or what you understand by alternative hypothesis. An ideal null hypothesis proposes no relation between the data set. Or in our above example, we can say no similarities as well. Alternatively, the alternative hypothesis says that there is a statistical relation is existing between two data sets. That means they are similar by some means. That can be of any means, but they can be similar. Now, the null hypothesis can be defined as H0, where 0 defines null, and alternatively, the alternative hypothesis can be represented as H1 or HA. A stands for alternative. Once again, the null hypothesis defines no relation, or usually it is the negative relation, and alternative hypothesis believes that there is a similarity or relation between the data. How to find out whether the null hypothesis or the alternative hypothesis are true? How should we understand out of these two which one is actually valid? Now, to realize that point, we have to understand how the hypothesis testing should be carried out. Here we will understand what are the phases of hypothesis testing and how we supposed to do that. The very first step of any hypothesis testing project is to identify whether or what are the hypotheses. So define hypothesis. At this phase, we will define the null hypothesis, and at the same point in time, we will also define the alternating hypothesis. Step number 2. Once the hypotheses are being defined, we should define how I supposed to analyze that. Analysis of the hypothesis. Here at this point, we should be also identifying that how many variables we are talking about. In our previous example, where we had A and B, two individual data sets defined, that means at this time we are not talking about one single variable, rather we are talking about two variables. So here at analysis phase or planning for the analysis phase, we should identify that how and how many rather variables are present, and based on that we should define one sample or two sample hypothesis testing. One sample hypothesis testing where we have only one variable or a data set on which we are trying to analyze the data, and subsequently, as the name suggests, where we'll have two variables or two data sets to be compared within each others or among each others, we will be calling it a two sample analysis. Once this second step is done and you have understood how many variables are there, and then based on that you have also selected what type of analysis you wanted to perform, the third step will be to find out or to analyze the actual sample data, or we also call it execute. Now, during this execution phase, whether you perform one sample test or two sample test, the result of this analysis supposed to be carried out as a p-value. Now, this value is called a small p-value. How the small p-value will be significant to us to determine which hypothesis is actually valid. Assume that there can be a value of this variable p as 0.0013, or alternatively in other cases maybe the example is 0.0714. Now in these two cases we have to understand which are these two values represents. Now the range of the p-value are actually broadly categorized into two parts. Either the p-value can be less than or equal to 0.05, or the value can be greater than 0.05. Now, if the value is less than 0.05, that means the alternative hypothesis will be stable here. And if the value is actually greater than 0.05, then the null hypothesis actually stays here. Once again, a quick summarization of this particular point. You have one ideology to remember this phenomena. In data sciences, there is a very popular statement where we call P low, null go. Here, the null means the null hypothesis. So if the p-value is less, then the null hypothesis will be invalid, and the alternative hypothesis will be playing a major role here. So once again with the values, if the value is greater than 0.05, then we will say hypothesis null, or the null hypothesis is valid, and if the value of p is less than 0.05, then we'll say the alternating hypothesis is actually true. Now, with the results, we can always go back and cross-check the defined hypothesis and take a conclusion about that. Now, after this, we're gonna understand what all methods we have in R and how we're supposed to define that. Let us understand what are the two types, or very popular two types, of analyzing or analysis can be done to validate a hypothesis. The first component, where I have one variable, the statistical method suggests that we should go ahead and perform something called one sample t-test. And if at all I have got two variables, then I should perform two sample t-test. Now here, the sample word, the meaning of this word sample defines multiple different sets of values which can be available. That means how many variables in short you have in your analysis plan. Let us take one quick example about two different situations and try to realize what all different analysis can be carried out on that and how you supposed to form the null or alternating hypothesis here. Once again, we are assuming there are two data sets, A and B, where A defines the marks of a mathematical test or a maths test, and the marks or the B variable defines the marks of a programming test. And we might have 5 observations of 5 students. Now, first of all, let us have these values and then probably we'll try to realize what happens here. Once again, the values are for one particular student or for every single student who has taken the test. For them, the marks are respectively 89 and 19, 85 and 66, 90 and 12, 81 and 76, and finally 83 and 26. Now here we have to remember how we supposed to form the hypothesis. Once again, the null hypothesis will be defining there is no relation, whereas the alternating hypothesis will be defining that there is a relation between multiple data. Once again, at this point in time, I am assuming that there are two variables in my analysis, so I supposed to perform a two sample t-test. But before going into the analysis, let us understand what all different variations or what all hypotheses we can form. The first hypothesis, the H0, what I am forming, let us see that. The first hypothesis here says that if any student is good at maths, then the same student may not be good at programming. Alternatively, in the alternative hypothesis, we will be talking the opposite side of this same first hypothesis. Here we will say if any student is good at maths, then the same student is also good at programming. It's 12:45. Now, how I supposed to analyze this and how I supposed to understand? What I have to do here, we will definitely go ahead and try to perform a two sample t-test. Now, As an outcome of two sample t-test in R programming, I supposed to get a value which supposed to be P. Now, if at all the value of P is low and the value is as lower than 0.05, as low as 0.05, then I will say the alternative hypothesis is standing here. That means the student is, if at all the student is supposed to be good at maths, the same student is also good at programming. Now let us try to understand how this thing's supposed to work out. Let us see the practical example in R. Okay, friends, let us once again try to see two data, which is the first one A, which defines all the elements of the first data set, which we have taken in our example as the collections of math test marks, which was 89, 85, 90, 81, and 83. Similarly, for the second set, B set, where the marks of the programming test was being considered, which was considered as 19, 66, 12, 76, and 26. Now, as there are two different set of variables available, we should go for two sample t-test. Now, let us see what was the t-test. And once again, before that, the null hypothesis was there. If any student is good at maths, then the same student may not be good at programming. And of course, the alternative hypothesis was if any student is good at maths, then the same student is also good at programming. Let us see how we are supposed to perform the analysis. Initially, we will say, as this is part of the T program or the T set package, we are calling it t.test, and at the same situation, we are passing A and B. First of all, let us get these two variables loaded with their collection, and then finally, we will perform the t.test A comma B. Now, once I perform this particular execution, I will be getting my data and I'll be getting the T value, the DF value, but most importantly, I'll be getting my P value. Now, what is the P value here? The P value is 0.02. Now here, what I have to identify here is whether this P value is less than 0.05 or not. Looking at this particular value, it is very, very reasonable to understand that this particular P value is less than 0.05. And then we once again focus on the ground rule of P value related to hypothesis testing, where we say if P is low, then the null hypothesis goes. Once again, the null hypothesis, what we have decided upon was if any student is good at maths, then the same student may not be good at programming. But here, as the P value is less, then we should also define that this particular value is suggesting that the students who are good at maths supposed to be also good at programming. Here we can see multiple other examples also. In another example where we try to perform one sample t-test, let us see what can be a situation. Here I am creating one more new scenario where I am having only one variable and the collection can be defined as 56, 21, 56, 24, 32. And then if at all, these are the scores of one single test for 5 different students, and I wanted to identify whether all the students are good at this subject or not, then let us see how I have to define that. I am assuming that the pass marks for this particular test was at 25. And now I am trying to define my hypothesis here. Once I have defined my hypothesis, whether the null hypothesis says the students are not good at this particular subject, whereas the alternative hypothesis says the students are supposed to be good at these subjects. Let us see how I have to define this component. So here I will once again start my t-test, but this time as I have only one value, I'll mention that value and then I will define what is my mu. The parameter mu here will define the cutoff range on or based on what I am trying to make the test. Here once again we can see the p-value is significantly lower. That means if the p-value is very low, the null hypothesis will not be standing here, and then that means the alternative hypothesis is actually correct. Similarly, we can perform multiple tests or multiple analysis for one sample or two sample t-test. Once again, a quick summarization. One sample t-test should be performed with one variable and one cutoff value, whereas the two sample t-test should be performed on two different distinguished variables. For more case studies, stay tuned to this channel, and if you have liked this video, if you have learned something new, don't forget to like and share. Thank you.